Okay, so today we are going to start chapter 6. Today we're going to change our unit of measure, and instead of measuring things in degrees, we're going to be measuring them in radians. So this chapter 6 is going to be just like chapter 5, but now we're going to be using radians. So now when we use our calculators, we need to double check that they are in radians. No longer do we need the degrees. Now, if you've cleared the memory and you have not turned it back into degrees, your calculator, the default, after you reset it or clear, it's back to radians. But again, the way to switch it, instead of, highlighting the word degree, you're going to highlight the word radian. So before we begin this, we need to define what a radian is. And a radian is an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle, and it has a measure of 1 radian. So let me show you what this means. I know that was a mouthful. So here is my circle, and notice I have an angle in here labeled as theta, and it is bound by this radius, and this is also a radii. So remember, wherever the radius is drawn in your circle, they all always have the same measure. Now, in order to measure an angle and have a measurement of 1 degree or 1 radian, the arc length also has to have a measurement of r, or the same as the radius. So what you need to know is theta here, when it's got all the sides are proportional and the arc length, they all have a measurement of r, it's equivalent to 1 radian. And 1 radian, the equivalent in degree form, is about 57 degrees. So again, you should know about how much 1 radian is equal to, and it's equal to about 57 degrees. Now, last year in geometry, we did a lot of conversion from degrees to radians and then radians to degrees. So if 1 degree is approximately equal to pi over 180 radians, that is going to be the conversion factor that I use when I convert. And then I also know that 1 radian is equivalent to that reciprocal, so 180 over pi. So we're going to practice this, and we're going to do a few problems converting from degrees to radians and radians to degrees. But before I move on, I want to show you where the integer value of the radians are located. So on my circle, notice I've labeled that 1 radian is about this measurement. It's about 57 degrees. 2 radians would be over here. So it would be this angle measure. So 57 times 2, it's about 114 degrees in degrees. 3 radians is about the semicircle. 4 radians would be over here, so maybe around 210. 5 radians over here, it's located in the 4th quadrant. And then 6 radians are over here, it's almost the full circle. So know approximately where 1 radian is located in that 1st quadrant, 2 is in the 2nd, 3 is it's at the 180, it's the semicircle, 4 is in quadrant 3, 5 is in quadrant 4, and 6 would be the full circle. So let's go ahead and practice converting. I'll give you a degree, and I'm going to ask you to convert it to radians. And know where the integer radians are located. So 1 radian, that's an integer, is located about there. 2 radians, that's the next integer, is located about there. 3 right here at the semicircle. 4, 5, and 6. Know where those integer radians are located. So this is just a screenshot of the textbook, what I just had handwritten. So again, these are going to be the conversion units we're going to use, or the conversion factors. Okay, so here's my first example. I want you to convert 45 degrees into radians. So again, I'm going to use my conversion, which is going to be pi over 180. So I'm going to do 45 times pi over 180. Now, before I multiply, I always like to simplify. You could multiply it straight across. You could get 45 pi over 180 and then simplify it now. I'm going to simplify before I multiply. I know that I could divide 180 evenly by 45. So 45 goes into 180 4 times, and 45 goes into 45 once. So my simplified answer is going to be pi over 4. Now, this value that I just got, or this answer, is the exact value. So when it asks for an exact value, you're going to leave it in terms of pi. When you're doing the homework tonight, the very first few questions are going to say leave it in terms of pi, and we're going to leave it like this. Now, if they say to approximate it, or if it's something that's not going to simplify like this, we will use our calculator. So if they say give an approximate value for this, on your calculator there is a button. It represents pi, and you have to use the second key to get to it. It's over there by the up thing, the up caret. So you would hit, so to get pi, you're going to hit second, and then this button here on the TI-84 and 83s. That will give you pi. Now, if I want an approximate value for this, what I'm going to do on my calculator is pi divided by 4, and this is approximately equal to 0.7854 radians. Now, if you think back to what I told you at the beginning, I told you that 1 radian was approximately equal to 57 degrees. Now, in this problem, I just asked you to find 45 degrees. And if I see that 57 is 1 and 45 is a little bit less, then my answer here of 0.78 is reasonable, because 0.78 is a little bit less than 1. And so is this a little bit less than 57. So my answer of 0.7854 is a reasonable answer. So again, you should use the 57 degrees as like a reference point for you to make sure your answers seem reasonable. Let's try another one. We're doing exactly the same thing on the next 2 examples. Slide here. Then now we're going to go the other way. We're going to multiply the given degrees, 330, by its conversion, which is pi over 180. Again, I'm going to simplify before I multiply. I like to cross off zeros when I'm simplifying diagonally. It's like dividing them both by 10. And then I can divide 33 and 18 by 3. So this will become an 11, and this will become a 6. And my final answer now is 11 pi over 6. This again is the exact answer. I want also an approximate value. So when you're doing the homework, the first section wants you to leave your answer like this. They'll say in terms of pi. The next section in the homework, I think it starts at like number 6. This is where you're going to use your calculator, and you're going to round to the hundreds place. So for this next part, I'm going to do 11 times pi divided by 6. Once I do that, I'm going to approximately get 5.7. I'm going to round to the tenths place, so 5.76. And these are radians. The next one, I'm going to do exactly the same thing. They're giving me degrees, and I'm going to convert them to radians. So again, I'm going to take 90. I'm going to multiply it by pi over 180. I am going to simplify before I multiply. So I could cross a 0 off on both, and then I can divide them both by 9. This becomes a 1, this becomes a 2. And now I'm left with pi over 2. And these are radians. Now, just to show you back on the circle, like for example, for the 90 degrees, remember my circle looked like this. And remember, my 90-degree angle would be right here. Remember, 1 radian was about here. 2 radians was about here. Notice when I get my exact answer here, I got pi over 2, but my approximate value is going to be pi divided by 2, and it's going to be about 1.57. Notice my 90 degrees is halfway in between 1 and 2, so again, it's reasonable. So again, when they ask for exact answer or leave it in terms of pi, this is your answer. If they ask you to approximate it or use your calculator, you're going to use your pi button, and this will be about 1.57 radians. I could have done the same thing on example 2. Again, remember 5.76 radians. Remember 5 radians was about here and 6 was here. 330 degree angle, if I were to draw this, I'm going to go around 270. And then if I go a little bit more, that's about a 330 degree angle. Notice 5.76, it's in here between 5 and 6 radians. So again, the answer I just got here is reasonable. Okay, so you should know these reference points from this very. Now I'm going to convert in between from radians to degrees. For this conversion, I will flip and make the 180 over pi this time. So I'm going to take my 5 pi over 6, and I'm going to multiply that by my conversion, which is 180 over pi. Notice my pi's will cancel. And then I could also simplify the 6 and the 180. 6 goes into 6 once, 6 into 180 30 times. I will multiply what's left, and that's 5 times 30, and it's 150 degrees. The next one, I'm going to do exactly the same thing. I will take my radians and I will multiply them by 180 over pi. 3 pi over 4 times 180 over pi. I'm going to simplify before I multiply. I'm going to cross off the pi's. I can also simplify the 180 and the 4. I know 4 goes into 180 45 times. So I will simplify that and make that a 45, make that a 1. And now I'll multiply what's left. 3 times 45, and that's 135 degrees. One more example of converting. This time I don't have a pi in my answer, so I don't have any pi to cancel. But I'm still doing exactly the same thing. So I'm going to multiply 5 times 180 over pi. Again, the pi doesn't cancel, so I'm going to multiply 5 times 180, and I get 900 over pi. So again, if it asks for an exact or leave in terms of pi, that would be your answer. However, if I asked you to give me an approximate value, what you would do here is 900 divided by pi, and you will get approximately 286.48 degrees. And again, this seems reasonable. Remember, here's your coordinate plane. If I were to locate 5 radians, it's about here. 286 degrees. Remember, you would start here, go around 270, and then maybe go a little bit more. So 286 might be about there. So again, it's reasonable. They're both in the 4th quadrant. So you should be familiar of where they're located. Now, if any of your numbers do not have the word radian next to it, as long as it doesn't have the little degree symbol, you're going to assume that it's a radian measure, not a degree. Okay, all the degrees are going to have the little degree symbol next to it. So if there's no little circle there, know that your measurement is already in radians. The next slide just has some common angle measurements that are in degrees and their equivalent radian measures. Okay, these are some common ones that you should be familiar with. Again, knowing that very first slide of where 1 radian is located, 2, 3, 4, 5, 6, and then know where these common angle measures, like the 0, the 30, the 45, the 60, you should know their exact and their approximate values. Again, to get the exact, just do the conversion. Let's say you blank out and you forget what the radian measure for 30 degrees is. Remember, you could just multiply it by pi over 180. And then once you simplify.
Pardon the eruption, but Anthony Gutierrez and Felicia Kozlowski, please report to student services. Anthony Gutierrez.
Okay, so these are some of the same exact measures we saw back in chapter 5. So be familiar with the degree measure and its equivalent radian measure. And then if you needed to convert it, again, all you do is divide the numerator by the denominator. Again, here is a circle. Notice 180 degrees is equivalent to pi, and the 360, the full circle, is 2 pi. Now again, if you ever forget, you can always convert. This is in radians, so to get it in degrees, you know you have to multiply it by 180 over pi. The pi's cancel, and that's how you turn pi into 180 degrees. Let's say we went the other way, and they gave me 360, and they want the radian. Multiply it by pi over 180. Simplify, and you get 2 pi. So just realize the full circle is 2 pi, the semicircle or the 180 degrees is just pi. And we have 2 more formulas. Now, we did this last year in geometry, and then the same thing here, what we're going to do next, the arc length and the area of the sector. Everybody good so far? All right, 2 more formulas. Now, last year when we found the arc length or the area of a sector, remember we probably for the arc length, we did what part of the whole circumference was it? And same thing for area of a sector, what part of the entire area of the circle were we looking for? So for the arc length, the formula is S is equal to R times theta, where R is your radius and S is the arc length and the theta is theta. It's the arc length, the theta is measured in radians. So if your theta is given to you in degrees, we need to convert it to radians first. Now, if you'd rather convert it within your formula, you can do that also. And I'm going to show you that in the second example. The formula for area of a sector is A is equal to 1/2 radius squared times theta. Again, theta needs to be in radians. So if it's given to you in degrees, you must convert it to radians. Now, when you're doing the formula, if you'd rather, instead of multiplying it by 1/2, you could change that 1/2 to 0.5. You're using your calculator for these formulas, so it doesn't really matter. Now, remember the formula for area of an entire circle is pi times radius squared. So if it asks me to find the area of this sector, what I would be doing is finding the area of the entire circle and then multiply it by the piece that's there, which is 90 degrees. So what part out of the full circle is 90 degrees? And that would be 1/4. And then I would multiply that by the entire area. So 4 pi. And my answer here, the area would be pi. In this case would be units squared because I didn't give you anything. Now, the next two examples, I'm going to give you the radius length and I'm going to give you theta. So let's go ahead and try it. So here, notice it's giving me a circle has a radius of 18.2 centimeters, and it also has theta, which is equal to 3 pi over 8. It wants me to do both formulas, the arc length and the area of the sector. Now, notice my theta is already in radians, so I don't need to do any conversions. All I'm going to do is write down the formula. S is equal to R times theta, and that's what I'm going to put in my calculator. So I'm going to do, my radius is 18.2, and my theta is 3 pi over 8. So I'm just going to put it straight into my calculator. You can do it however you want to do it. I'm going to do 18.2 times 3 times pi, and then divide by 8. Once I do this, the arc length is approximately 21.4 centimeters long. To find the area of the sector, I use the other formula. Let me go over here. So for that formula, its area is equal to 1/2 the radius squared times theta. Again, my theta was already in radians, so I'm just going to replace everything. So you could either do, leaving it as 1 divided by 2, or you could divide it ahead of time if you know that 1/2 is 0.5. 18.2 squared. If you want to write it as 18 times 18, however you want to enter it in your calculator. Many of the calculators have a square button. So this squared times 3 times pi divide by 8. So in my calculator, what I'm going to do is 0.5 times 18.2 times 18.2 times 3 times pi divide by 8. Once I key all that in my calculator, I get approximately 195.12 centimeters squared. If you didn't want to do 18 times 18.2 times 18.2, you can also key it in this way, because there is a little exponent there. You just hit that button and it'll square it. Again, to get to the pi, you got to hit the second key and then that up arrow. The next example, my theta is in degrees. So I need to decide, am I going to convert this into radians first, or will I just do it straight in my formula? So again, remember to find the arc length. It's radius times theta. So I'm going to plug it in, 18.2. But now what I'm going to do is, I'm going to do my conversion of degrees to radians right here. So 144 times pi over 180. If you want to do this calculation ahead of time, get that answer and then times it by 18.2, you can. Otherwise, what you can do on your calculator is 18.2 times 144 times pi, and then divide by 180. This should be approximately 45.7 centimeters. We're going to use the same information and now use the other formula to find the area of the sector. So that formula is area is equal to 1/2 radius squared times theta. So again, I'm going to replace my radius and my theta. So area equals 1/2 times 18.2 squared. Again, my theta needs to be in radians. So the same thing I wrote right here, I'm going to write again. So 144 times pi over 180. Once you key all of this in your calculator, the area of that sector is approximately, squiggles here, 416.25 centimeters squared. Remember the units on any area, whether it's the whole figure or just a piece of it, the units are always squared. The arc length is going to be whatever the units are given to you, and these were centimeters. So these are the formulas that you should remember. Also remember that the arc length is always going to, the measurement of the central angle is the same as the arc length in radians. So when you're looking for your theta, the central angle measure is what you're using. And just make sure it's in radians and not degrees. So your homework for this section, it looks like a lot, but it goes really quickly. 1 through 17 odd, 21 through 33 odd, 43 through 51 odd, and 69 through 79 odd. And then tomorrow we will cover 6-2. So you can go ahead and get it started. The beginning part, when you're doing the 1 through 17 section, the beginning part is leaving in terms of pi. Then the next set of instructions, actually use your calculator and give me the approximate value. So if you're not clear on the instructions, you can come and ask.